Welcome, soldiers. Thank you for studying the art of warfare. Thank you for following this channel and giving your immense support. Believe in God. Love your fellow man. Eat healthy. Train your body. Take care of your equipment. And now something you already knew: liquid rocket fuel powering humanity's journey beyond Earth. Since the dawn of the space age, one force has propelled humanity's most ambitious machines into the skies: liquid rocket fuel. And like solid propellants, liquid fuels offer extraordinary precision, controllability, and power, making them the backbone of both space exploration and military missile technology. The science is elegant yet complex. Liquid rocket engines rely on two key components: fuel and an oxidizer. Common pairs include liquid hydrogen and liquid oxygen, used in NASA's Saturn V, or the more stable kerosene-based propellants like RP-1, which powered the legendary Apollo missions and still drive today's SpaceX Falcon 9 rockets. When combined under immense pressure, these liquids ignite in a controlled explosion, producing the thrust that lifts rockets from Earth's gravity. Liquid fuels offer one critical advantage: throttle control. Engineers can regulate the flow of propellant, allowing rockets to adjust speed, restart engines in space, and even perform delicate orbital maneuvers. This flexibility is why nearly all crewed space missions depend on liquid engines, but liquid propellants come with challenges. Cryogenic fuels like liquid hydrogen must be stored at temperatures near absolute zero, while others such as hydrazine or nitrogen tetroxide are highly toxic, demanding extreme safety measures. Handling, storage, and fueling are as much an engineering art as the engines themselves. In the military sphere, liquid fuels once powered some of the most feared ballistic missiles of the Cold War, offering massive thrust but requiring long, vulnerable fueling times. Over time, they were gradually replaced in many systems by solid propellants for rapid readiness. Yet for space exploration and advanced rocketry, liquid fuels remain unmatched. Today, every major spacefaring nation relies on liquid propulsion. From launching satellites to sending probes to Mars, liquid rocket fuel is not just a chemical mixture, it is the lifeblood of exploration, the fiery breath that carries humanity from the Earth into the cosmos. So when we look at a rocket soaring skyward, we are truly watching the raw power of liquid fuel science, engineering, and controlled chaos working together to overcome gravity itself. Thank you for following this channel and giving your immense support. Goodbye. Bear witness to the race for knowledge. We wish you a pleasant rest of the day.